Hello Gators, this is 8.6, finding the area between curves that intersect at more than 2 points. Let's take a look at an old problem from the last lesson, and I want you to know that I've done it wrong, and I want you to notice what I'm going to do to help correct myself. I'm trying to find the area between these two curves from 0 to 1. Y the upper minus y the lower. I have definitely done it incorrectly. The lower is being mentioned first, the upper is being mentioned second, but I want you to follow my mistake. I am going to sum all of it up, my rectangle, and I'm going to take the definite integral and the antiderivative, and I'm going to get a negative answer. And this is not the correct answer. The answer is positive 2/5, positive 2 5/6, sorry. So I want to show you what you can do without having to erase and start all over again. What you need to understand is that this definite integral is going to give you a negative number. So you can take the absolute value of it, which means you are going to take the absolute value of this and the absolute value of this and the absolute value of this, and your correct answer will be 2 5/6. So don't rewrite the problem when you know you have made this mistake of switching the upper and lower. Just take the absolute value and that will be the area answer. And this is okay with AP. Let's take a look at a curve that intersects in more than one point. Notice that I have set them equal to each other, and now I have it in factored form. So my first x value is -2, my next x value is 0 intersection, and my next x value intersection is +2. And so right here, this is the value x equal to -2, x equal to 0, and x equal to 2. Now when I draw my rectangle right here, you can see my upper will be my cubic and my lower will be my quadratic, and it'll reverse itself in this region is right here. So I'm going to go to the next screen and show you that I've drawn these already. And here we go. And so I've drawn them already, and again I'll write down my values here again, -2, 0, and 2, and I'm going to show you how we can set up our integrals. Okay, so the area will be equal to the integral from -2 to 0, and my upper will be my f of x, and you can actually write f of x because f of x has been mentioned, so the grader will know what you're referring to, minus g of x, and then dx, plus the integral from 0 to 2, and our upper is g of x minus f of x and dx. Now all we had to do was set up the integral. This integral will give us the area between the two curves. Now let's take a look at evaluating it another way. And what we can do is, again, this is -2, 0, 2. We can actually, the area can be equal to the integral from -2 to 0 of f of x minus g of x dx. And if I want to continue my f of x, g of x, I just have to know that that's going to be a negative value, and I have to intentionally decide I am going to put an absolute value there so that I don't cancel out area here. All right. And let's take a look at this problem. The figure below shows these two curves, and we want to find the area. So this is going to be rectangles, upper minus lower, and I went ahead and solved find the intersection of these two curves, and they're at -√2 and √2. So these are going to help me with my limits of integration. So my area will be equal to, the first area will be the integral from -2 to -√2, and my upper will be 1 minus my lower, which is 2 minus 1/2 x squared, and then dx, plus, and then my next integral will be from -√2 to √2, and that'll be my quadratic in my upper, and then minus 1 for my lower. And then I have one more here, integral from root 2 to 2. And again, I reverse myself, 1 minus 2 minus 1/2 x squared dx. Okay, and so there's 3 areas here, this area, and this area. I do want to talk about one more way to do this problem. And to do this problem, there's a lot of symmetry here. And so if I find the area of this, and then double it, then it'll be the area of all of this together. So another way to set it up is to just set up from 0 to root 2, and then root 2 to 2, figure out this definite integral, and then times it by 2, and you will get the same area as we did in the last problem. And that's the end of the screencast.